Unit testing. Let's do this. All right, so this is our first 116 proper topic. I'm excited because the first 2 weeks, it's pretty much 115, but in Java is pretty much all we've done so far. Yes, we added strong typing and memory diagrams, so we got some new stuff out there. But this is, in my opinion, the first 116 proper topic. And you'll notice that when we get into this content, the pace will slow down. I'll sometimes slow down my speech. This lecture, not so much, based on the previous section. I didn't slow down too much. But as we're getting into the 116 stuff where I know it's new concepts for you, I do want to slow it down, cover less material each time. So if the last 2 weeks went at a blistering pace for you, don't worry, that won't continue all semester. But unit testing. Let's talk about it. So how do we know if our code is correct is the big question that I want to ask and that you should ask yourselves, and I won't have a good answer for. Not a 100% good answer for. But I want to at least give you guidance. The short answer, the spoiler for that one is it's up to each of us to decide how to decide if our code is correct. But I want to show you the tools we'll use, and then then we'll revisit that question. So how do we make sure that our code is correct? There's kind of a progression that I think we all go through when we're first asking ourselves this question, where the very first step in this progression is, well, just submit it to Autolab. You're a student in CSE 115, you either submit your UB Infinite problem or you go to lab, you submit to Autolab. If it gives you points, your code's right. Easy. Easy day. This is fine for a start. It's what we should do in 115. To an extent, it's what you'll do in 116, except Autolab is going to be testing your tests in addition to your code. But it's not viable for the future. You can't graduate from college only knowing how to submit your code to Autolab and have Autolab tell you it's good. Because when you got out there in the workforce, Autolab won't exist. Nobody's going to be there telling you, hey, this is right or this is wrong, except your end users after they find bugs. And if that happens, it's bad. Yeah, it's too late at that point. You've all used buggy software before. We don't like that. We're not going to use that product unless we don't have a choice. So that's bad. We don't want that. So we need to figure out some way of actually testing our own code. And at this point, this is where I expect you all to be, is call your method, print out the result to the screen, whatever it returns, and look at it with your eyeballs and see if it prints out the right thing. And this is really good testing so far. And to be honest, I'll still use this form of testing, and you all should too, in my opinion. From time to time, when I have a small portion or a small project, just something I need some quick and dirty testing, this is perfectly fine. Write a main method, call your method, print out the result, verify if it's doing the right thing. Good old print line debugging. This is hard to get students to this point in 115, but hopefully I would expect every single one of you to be at that point now. Hopefully you made it this far that you actually did start doing that. But like midway through 115, students usually start feeling the pain of, I can't just one-shot these methods completely blind anymore, that I need some way of testing this stuff before I submit. And they go to office hours, and the TA walks them through writing a main method, calling their methods, etc. Hopefully you all went through that process. If not, you can visualize what that means. Call your method in a main method and see if it prints out the right thing. And if not, the next slide is going to have examples of that anyway. Here in 116, we want to take this to the next step of the progression, unit testing. We're going to take that idea of printing your results and checking them with your eyeballs, calling your methods and checking them, but automate it. We want to automate that and have code that's going to do that for us. That's our goal today, and that's our goal throughout this semester and throughout your careers, to be honest. So what we want to do is write code that's going to run a series of tests. We're going to have various test cases, which will be input-output behavior. I'm going to call my method with this input. I expect this output, and have the code make sure that I did get that output on that particular input. And if our code passes all of those test cases, all of them, if it's right on every single challenge that we gave it, then and only then will we say it's correct. If it fails even a single one of those inputs, if on a single input it doesn't give us the right output, our test says, nope, that code's wrong. I don't care if you have 1 million inputs that you're checking and it's wrong on only one of them, that's still wrong code. We do demand perfection when we're writing code. We want it to be right in all cases. We don't want that one user with that one specific use case to have their code break, their copy of your program break, and they get all the bugs. We don't want that. We want it to be right on every input. So we write test cases to identify any bugs, and if it identifies any bugs, we're going to go fix that bug so our test cases pass. And bugs can be tricky to find. It's I'll leave it at bugs can be tricky to find. My music app, to figure out when to start and stop the music, I had I might as well tell the story. On Friday, it worked good for this lecture and the previous lecture, but at the beginning of the end of 3:12, the music wouldn't start. And I was wondering what the hell, why it wouldn't start at the end of the lecture, and then I went over by a minute. I have code that's, I have an API key that has to talk to the API, and I have code that says whenever it has to talk to the API, check to make sure that the API token did not expire. So send a request to the API, make sure the token's not expired. If it is, send a request to refresh the token and get a brand new token, and then make the request to start playing music. The token expired after the check, but before I sent the cue to go play. Milliseconds of timing, and the timing was absolutely perfect that the token expired in those milliseconds in between requests. So bugs can sometimes be really tricky to find. I was more impressed than anything when I found that bug. Like, that actually happened? That's ridiculous. But it makes sense because exactly 1 hour, tokens last 1 hour for the Spotify API. Exactly 1 hour before that, the token expired. I got a new refresh token at the end of this lecture. So the token, it was exactly 1 hour later to the millisecond. And, some variance in network delays to push that off one direction, 1 millisecond is enough to have that bug where even though I'm checking to make sure the token's valid and refreshing the token, still didn't get what I want. So I fixed the bug anyway, but bugs can be hard to find, needless to say. So we want good unit testing. And whenever I have bugs like that, when I'm talking about unit testing all semester, you have the obligation to make fun of me for it. Professor, you need more testing. So let's talk about testing, which I don't know how I would write a test for that. It's something I just had to have a bug, I think. But so let's do some testing. This is the method we're going to test in today's lecture. Very beautiful method. Took me a while to write this one. I don't think there are any bugs in it. But if this were a programming task, this would be the description. Write a method named add5 that takes an int as parameter, returns an int, and the returned int should be the input int plus 5. Jesse owns, I own Spotify. I'm a user of Spotify. So this would be the description, and here's my beautiful code. I'm pretty sure it's correct. And for this one, yes, I'm using this as an excuse to do some testing. But for this one, would we really test this method? Probably not. We're just going to look at the code and say it's obviously correct. It's usually a dangerous thing to do, but when we're adding 5, I don't know. I wouldn't be mad at you if you didn't test this code. But I don't want to be bogged down in details by giving a more complicated piece of code to test. So we'll test this very simple method. So we're not distracted by the method itself. And here's what I would expect you to do right now if I said, test this method, make sure it actually does what it's supposed to do. You would do something like this. You write a main method, you'll call your method several times, print out the results, and then verify with your eyeballs, did it do what it was expected to do? So the first thing I print out is add5 of 2. I would expect that to return 7. So I check the first thing I print to the screen is 7. Feeling good about that. 5 plus 5 is 10. 1 plus 5 is 6. I'm getting the right values here. And I'm feeling pretty confident that my method is, in fact, doing what it's supposed to be doing. There's no strange things that went on. I didn't use any different Unicode characters to say that that's not an actual file. You know, nothing weird like that happened. So, because I could have wrong code here, potentially. Everything went good. Verify, it's fine. Good. But what happens when this is a more complicated method? For, I think it's test 5, but later in the semester, you're going to write a method that's going to sort songs by either title, artist, or average rating based on its Bayesian average rating. And if I give you an input, or if you want to make sure that it works with lists of songs that are 100 songs long, for example, you're not going to do this. You're not going to want to do this anyway, where you're creating a list of 100 songs, you're calling your method, printing out 100 songs to the screen, and manually verifying that every song is, in fact, in the right order, even if that's 3 songs, because realistically, you're not going to write a test case with 100 songs. But even when you're writing your test case with like 3 or 4 songs, and you have 5 test cases, you're not going to look through those every time. It's going to get tedious. It's going to get tough. When you're out there writing industry code where you have a project that's millions of lines of code with hundreds of classes and thousands of methods, and you want to test them all to make sure it all works, you're not going to look through hundreds of pages, tens of thousands of lines of output and manually verify. It's just not scalable. This isn't feasible beyond, well, 115. It's not feasible beyond 115. Again, except for like small methods. I've written plenty of code where this is the way I'll test. But not once your code gets large, which is the theme of the course. How do we write large programs? So we're going to write unit testing. We're going to automate this. So I'm doing the same thing. I'm going to call my method 3 times with these 3 inputs. And I'm going to verify in an automated way that I'm getting the right outputs instead of verifying with my eyeballs. So I'm removing myself from the equation. Of course, I'm writing the code, but then you want to remove yourself from the equation when it's time to actually test your code. We want the machine to do the whole thing. So let's take a look at our first unit test. This will be in a separate file. It is a brand new class, the add test class in this case, which the add test class, which is going to test my adder method. So let's break this down and take a look at each piece of this class. This unit test class, which I'll call a test class. If you hear me call it a test suite, I slipped up a few times in the other lecture. I probably will here today, here too. When this course was in Scala, we called them test suites because that's what Scala tests called them. I'm going to call them test classes now that we're in Java, but it's ingrained in my brain to call them test suites still. So first thing, we're going to import the test annotation from the JUnit library. So we're going to use the JUnit library as our unit testing library for Java, which is pretty standard for Java. If you're using Java out there in your job, they're probably using JUnit. Hopefully they're testing it all. If they're testing it all, they're probably using JUnit. I don't know. They might be using something more fancy, but it's going to behave similarly to JUnit if they are. Any test library I've used in any language works pretty much the same as this, to be honest. Same structure. So we're going to import JUnit. This is a library that does not come with Java. It's our first, what we call external library, where Java, if you just download your JDK, set up IntelliJ, and try to run this, doesn't quite work. For us, it will, thankfully, but it won't just work out of the box. We do need to download and install JUnit and link it to our project. So to do that, you have to do nothing, absolutely nothing. So as long as you've cloned the repo, inside the examples repo and the starter code for the homework, there's a pom.xml file in there, which you may or may not have seen. You can pretty much ignore it, to be honest. It's so fantastic. I used to have to spend like half a lecture talking about this stuff. Now it's one slide, and I could probably skip it entirely. But that pom.xml tells IntelliJ that this is a Maven project. It's going to tell Maven to read that pom.xml. That pom.xml says, hey, we have JUnit as a dependency and this Hamcrest library, which JUnit depends on. So Maven will read that, recognize it, download JUnit, link it to your project, and then you're good to go from there. This all happens automatically when you clone the repo. IntelliJ notices the pom.xml and does everything in the background. All happens automatically. It used to not, and it was frustrating and painful. And I used to have to say, mark your sources folders, sources root. I don't have to say that anymore. Oh, it's nice. It's good. Modern tools are great. We can use our brain power to worry about other things, better things, bigger things, things related to the concepts of the course instead of logistics. So the reason I do still mention this is if you do see errors on this import line, like 99% of the time, that means that JUnit and this whole Maven and pom.xml process didn't work right. Something went wrong with that process. In most of those cases, it's because, for whatever reason, the student says, I'm not cloning the repo. Maybe Git wasn't installed properly, and they don't feel like figuring out that issue, and the TAs in lab couldn't figure it out quickly, and just something went wrong. So what they do is go to File, New Project, create a new Java project, go to the code in GitHub in their browser, copy, paste into their project, and start a brand new project from scratch, but they don't copy the pom.xml. So if you're seeing that issue, an error on this import, that's probably what you did. If that is what you did, the solution to that is grab the pom.xml, and then also copy that into the new project. Well, the real answer is set up your Git. You're going to use Git. If you're a computer science student, you're using Git for the rest of your life, probably, to be honest. Just start using it. Get it installed on your machine. But if you don't want to do that in 1.16, 2.20, you're required to use Git. You submit your programs through Git. Like, you're going to have to use Git. The other solution, if you do just want to hobble through 1.16 without it, is copy that pom.xml, create a pom.xml in your project, right-click, paste my pom.xml contents, right-click on the file and say Add as Maven Project, and then IntelliJ should go through the whole thing and set it up for you. So if you're having that specific problem, which might be none of you, but if it is, if one of you is out there, this helps. I want to get that, get you started on the homework and get around that bug. Or go to office hours. We can, of course, help you with that. Next, we have our first static import. This, if you don't want to do this, if that keyword static there scares you for whatever reason, you don't have to do this. This is optional. I think it's worth it. What we're doing with this static import is saying from the org.junit.assert class, I want to import one single static method. So I'm importing the assert true method from the org.junit.assert class. So I do that using the static keyword for a static import. And now I can call the assert true method without having to type assert.assert true. If you don't like that for whatever reason, just import org.junit.assert and then do assert.assert true, just like we did with our, never called a static method, did we? Just like you would when you import problem set in the homework code and you do problem set dot count sum digits. You could do it that same way as well. This is less typing. You don't have to do assert dot. That's why I like it. And when you have lots of asserts in your testing, you don't want to just type assert dot every time. If you do, by all means, do it like this, like add or dot, add 5. It would be the same syntax. Okay. The test annotation, it's JUnit. It's not magic. You do have to tell it what methods you're going to use as tests. So this @test annotation, which is the only thing we actually imported, well, aside from assert true, but what we actually imported from JUnit, we're going to use this @test annotation above the line where our method starts, which annotates this method as a test method. So that JUnit will treat this as a test method. Notice that test methods are not static, but they are public void, and they take no parameters. For what it's worth, set your tests up like that. Then JUnit will know what to do. JUnit will take it from there. And do not forget these test annotations. This is a very common mistake I see a lot when we're first doing unit testing. Don't forget these annotations. If you forget the annotation, JUnit does not treat it as a test, won't run your tests, and you'll either get errors because there are no tests at all, or you'll submit to Autolab and wonder why your tests aren't doing anything. It's usually because you forget that test annotation. So make sure it's there. It does have to be there. Just don't forget it. I don't have much else to say about it, but don't forget it. So it tells JUnit that that's a test method. And then the name of your method is going to be the name of your test. So I'm writing a test called test_add5. I recommend that you use good naming conventions here. I'm also not going to get mad at you if you don't, unless that's what's specifically causing confusion in office hours. If I ever have to say, well, because it's test 2, not test 3, then I might get mad at you. But other than that, I don't care. But I do recommend that you give good names here. Autolab will use these names. Whatever names you give your test, Autolab will give you feedback with those names. So be sure you at least know which name corresponds to which tests, so you don't have to keep looking back and forth through your code, or just look back and forth. But these will show up in Autolab. We're going to see in a few slides that we can have multiple tests in the same test class, and Autolab will give you individual feedback on each test. So if you have multiple methods marked as tests, Autolab will give you separate feedback, which will help you identify which of your tests is causing the issue in Autolab. So you're recommended to have more than one test here and give them meaningful names, so then your Autolab feedback will be more useful. And then we're finally ready to start writing tests. So that's the structure of a test class. Now let's actually start writing tests. We're going to call this assert true method. We're going to have a variety of assert methods that we can use. I'm going to start with just assert true, the simplest of them all. It's going to take a Boolean expression. And if that Boolean expression resolves to true, that test case passes. If it resolves to false, that test case fails. So assert true is going to assert that this resolves to true. If it doesn't, test fails. So I'm going to call my method. And since these are in separate classes, I have to say where add5 is coming from. So I'm doing adder.add5. And this is as good a time as any to mention, if two classes are in the same package, they don't have to be imported. Classes can see all of the other classes in the same package. So since these classes are both in the week 2 package, I don't have to import adder. Or otherwise, I'd have to have import week2.adder as an import statement. I don't have to because they're both in the same package, but I do have to call the method through the class name. Unless I added a static import, I could do import static week2.adder.add5 and then just do add5 without the adder dot here. I didn't do my static import, so adder, invoke the class, .add5, call the method. Yep. Yes, we won't in this class, but yes, you could do that. I don't know off the top of my head. I think there's a Java class that'll grab inputs like you would in like Python. You would do input, and then it'll grab everything from the keyboard until you hit enter. I think there's something like that in Java. I don't know off the top of my head. Mm-hmm. Oh, okay. We won't do that, mostly because we want to automate these things. And if there's still a human involved, we lose some functionality. But there are sometimes you do want to write a program that interacts with the human. Well, actually, any code we write, we do eventually want to interact with the human. So it is good stuff to know. Mm-mm. Nope, we're going to write it. We're going to hard code it all in our code, and then that'll be your tests. So whenever you think of a new input, you'll write another line of code for your next input. The syntax for test annotation, bless you, change if, import the whole library. So the annotation is defined by a class. So we could, I think we can do import org.junit and then do org.junit.test. Actually, do we even need an import if we do that? I think you can do org.junit.test down here. I don't know. I don't know off the top of my head exactly the intricacies of that. If you can import a whole package. Oh, no, yeah, you can't just import a package, right? But you can do org.junit.star and import everything in that package. And then you would still do @test right here. But I think you can do @org.junit.test and then just leave off the import entirely. I'm pretty sure. Is equal only allowed to be used with integers when comparing two values? I do have a lot more to say about this on Wednesday. For here, I'll keep it brief. You can use equal for more than just integers, but not with strings or doubles. And I'll talk about that all next lecture, why we can't do that with strings or doubles. But we can do it with array lists, incidentally. Wait, can we? Oh, no, not equal. I think equal, in this course at least, I think we only use equal for integers, now that I think about it. Everything else we have different ways of comparing them. Usually the dot equals method, if you're wondering. All right. So we have 3 test cases, a little bit of vocab here. We have a test class with, right now, just 1 test, and that test has 3 test cases. So if you hear, I'm never going to quiz you on that. On a quiz, it's not going to be like, what's the difference between a test case, a test class, and a test? But I will use that vocab. I'll try to stay consistent in lecture so you can keep track of which one of those 3 levels I'm talking about. Like for your homework, I'll only ever say write a test class. And it's up to you to organize your tests however you want, name your tests however you want, make your test cases however you want. I'm just going to say write a test class named add test that tests the following functionality. And assert true, I already mentioned what assert true does, but we want 0 bugs, we do demand perfection. So all of these have to pass or else the entire test class fails. And this is just a logistical note, but there's no main method here. This is a complete class. You can run this. Everything's fine with it. It's not necessarily done, but it does work. And there's no main method. And I said every Java program starts with a main method, so some of you should be wondering what the hell's going on with that. JUnit will have its own main method. There's a test runner class, which is actually ran and then consumes this class. It'll create an object of this type and then call our non-static method through that object. That's all handled behind the scenes by JUnit. So we're not writing a main method, but a main method is still running to be the start of the Java program. And lucky for us, I don't have the, oh, there it is, IntelliJ. IntelliJ will do all that for us. IntelliJ understands what JUnit is. It's common enough in Java that it comes with a JUnit plugin, and it's going to recognize this as a JUnit test class. So if you right-click the class or click the arrow right next to the class name, it'll know exactly what to do. It'll go to JUnit, invoke the test runner, and then run this in JUnit. Yep. No. No, but I would question why you want a main method. It won't be a conflict, but... wait, actually, I've never tried it, so maybe I should back off on my quick answer there. Because IntelliJ might get confused if you want to run the main method or run it using JUnit. They would need a way to distinguish between the two. But usually you don't want a main method in your test class. If you are writing a main method, you would put it right here. You would put it in your class that you're testing. And then in your testing, if you have a need for a main method outside of that, you would probably just write it as test cases. Yeah, I've never tried to put a main method in a test class. Now I'm wondering what IntelliJ would do in that spot. And let's return to our question. How do we know our code's right? It's going to transfer a little bit into this new question. Is this enough testing? When do we have enough testing? When can we look at our test suite and say, yes, that's enough testing? I know my code's right if it passed that test suite. I'm good with that. And I don't have a great answer for this one, because this is something that we all individually have to answer. When you go out in your careers, what level of testing are you comfortable with? When can you look at your test suite and say, if my code passes this test, or if somebody else's code passes that test, you're confident that that code has to be correct, even in situations where you can't see the code. So if I just said, I got a method named add5, it has all these properties, and I don't show you this, but I do tell you that it passes this test class. I did say test suite a few times there, didn't I? And I say it passes this test class. Are you 100% sure? Are you confident that that code has to be correct? And hopefully in this case you'll say no. I got 3 measly test cases. This ain't much. So how do we get confident that our code, that our testing is enough testing? Never a great answer for that. When you go out in the world and you're working on your team and building big pieces of software, collectively you'll have to agree what is the answer to this. How much testing are you comfortable with, or lack of testing are you comfortable with? When do you stop writing tests? Because we could spend the rest of the semester writing tests for this one method and cover every single possible int value, but we're not going to do that. So we got to figure out when to stop, or else it gets out of hand, but we don't want to stop before we've done thorough enough testing. That answer will be different for everyone. In this class, the answer is, at a very minimum, Autolab has to be happy. So Autolab's got to cough up those points. But that bar is usually lower. I try to make that not too strict. The bar is usually lower than what I would be comfortable with full testing, especially later in the semester. I do back off on how strict Autolab is, because at that point you should be able to write your own tests and answer that question for yourself at that point. A lot of students don't and just do the bare minimum until Autolab's happy and then stop writing tests, and then they come to office hours and say, why doesn't my code work? It passes your Autolab tests, but we'll have those conversations throughout the semester. But by the time you're done with 116, you should have the skill of being able to answer that question for yourself. Sit down, write a really good test class to test your code, because after 116, it's very rare that any professor, if any, I don't know if any do anymore, will actually test your tests. But the program assignments themselves are going to be a lot harder. You're expected to just have the skill of testing by the time you get there. So by the end of the semester, I do back off a little bit, not too much, but I back off a little bit and have intentionally bugs that I don't check in your tests. Why is the way we're doing it better than the input method employed by most coding competitions? For instance, the problem here, Code Forces, essentially uses /r in the input to separate multiple inputs. But they have code to parse that. Like their testing on the back end is going to have code to parse that format. And then somebody has to write that code. I see what you're saying, though. Like if I had you submit a text file and then Autolab would parse that, and I would do all that parsing, but that's not going to help you in your career. Like you can't write tests like that unless somebody on your team wrote that parsing code. What's the usual amount of test cases we should have? Yeah, that's the question that I'm asking. I'm asking you that. Everyone's got to answer that question themselves. For Autolab, for 116, at least until Autolab's happy. I would recommend going beyond that, but I know a lot of you don't. Can you put multiple tests in the same test class? Yes, we will do that in a second. Also, can you make the testing method before you make the method you want to be tested? Yes, it's called test-driven development, and it's something I encourage. I used to push a lot stronger, but God, it's hell trying to actually get students to do that. You all just want to write your code before your test. But I do recommend writing your tests before the code, but it's not something I'm stressing anymore. I do got to keep moving, but I'll try to keep at least one eye on chat. So this isn't, we all have to answer the question for ourselves, but hopefully we can all agree that this is not enough testing. And even saying that, the method is so simple, you could even argue that this is more testing than we needed because we're just adding 5. But If you actually want to write a thorough test suite to make sure that this method is correct, this isn't enough testing. Here's an incorrect solution, which if this were in Autolab, I'll have this cute little hint text, the cryptic message, a name for each incorrect solution in Autolab. And I'll talk about what that means. If you haven't submitted yet, I'll talk about what that means at the end of this lecture. I would probably call this one no negatives. It's going to add 5 as long as x is positive, but if x is negative, this is going to break down. It's going to give me the wrong answer. So the problem with this is that this test class, if I'm running it and this is the code that I'm testing, this test class is going to say, yep, that's good. That's great code. And it's going to pass this incorrect solution. So I would definitely say this is not enough testing. This is a pretty common bug that you're going to see, not necessarily this small little toy example, but it's a very common thing you're going to find in programming, that you write a method or your colleagues write a method and it works great a lot of the time, but not when the input's negative. When the input's negative, it completely breaks down. So this is something we want to be thinking about when we're testing our code. What should happen on different sets of inputs? So we have our small positive values, which are like our common test cases, which I didn't say it was on the previous slide. Our common test cases, this is what the method is most likely going to be used for most of the time. We got these small positive values, and it's got to add some, and it's got to add 5 to those. So next, let's add some uncommon test cases. These are test cases that you're likely going to see. Your method's going to see inputs that are negative like this and some larger positive inputs. But they're not going to be like the bulk of the inputs. But they're certainly going to happen, and we got to be right on these things. So let's add some negative inputs and make sure we're doing good on the negatives. And our goal here is to expose bugs. When we're writing test cases, we're trying to challenge our code. We're saying if my code has this specific bug, in this case isn't good on negative numbers, doesn't handle negatives, let's try to expose that bug with test cases. So let's find that bug. If it's not good on negatives, one of these, or all of these, is going to fail. And we're going to identify that bug, which is what we want our tests to be doing, identifying bugs, so we can go eradicate those bugs. We can update our code and make sure we're passing those test cases, i.e. we got rid of the bug. Yep.
So if you want to write put in something that will return an error, actually would you have to do that?
Not in 116, at least. So this is something you'll end up doing in industry, but we got enough to worry about. It's another one of those things where we don't need to dive too far. So with this method, we actually can't get an error. We can get syntax errors. Like I can call this with negative 1.0, which is a double, and it's going to be a type mismatch. But in that case, the code won't even run. So our test case can't even identify that as a bug, because it would be an error in our test code specifically. But when we start having methods that take like array lists, we could always give it null and check to see what should happen in that case. I'm not going to do that to you in 116, because then it just adds the tedium of every method you write has to start with, if the input is null, do this special thing. I just don't see a benefit to that. There are other cases where the method might actually crash on a certain input, and we're not going to do that in 116 either. If it crashes, the test case will technically fail, and Autolab will count that as the test case failing the solution, which should only happen on incorrect solutions. So that'll be fine if it crashes in this class at least. In industry, you would want to say if it throws a certain exception, catch that, and then if you were expecting it to throw that exception, handle that gracefully and say that it's good. But yeah, not something we'll do in 116. So we do have a test class with 2 tests in it now. This is allowed and in fact encouraged, especially like homework task 1, where you have 3 different methods that you're testing in one test class. At the very least, I would have 3 methods for each of the 3 methods that separate test methods for each of the methods that I'm testing at a minimum. And each one of them, make sure you annotate them with the @test. If I leave off this @test, this method will be ignored by JUnit, and I'm only going to be running one test. In Autolab, you're only going to see feedback on one test. You're not going to get the behavior that you want. So add another test annotation, and both of these will be ran when you run the test class. And now we have a test class that when we run it, on a correct solution, it's going to pass and say, this code's good. When we run it on this incorrect solution, all of these tests, well, in fact, just this one, and then the rest don't run because the test already failed. This one is going to fail that incorrect solution. Since that incorrect solution failed at least one, it only has to fail one test case, then it's this test class says that this code is no good. This code is incorrect, correctly labels it as incorrect, and we're feeling better about that. And then I throw this code at you. I have another incorrect solution in Autolab. I'd call it bad on 0. And it has crazy code that, only a crazy person would write code like this for a method that's supposed to just add 5. But if I have code like this where if it's positive or negative, I'm doing the right thing in a convoluted way. But if it's exactly 0, I'm just returning X. And it's wrong only on 0, but right on every single other input. So we want to add some more tests here because I got a pretty common situation where your test is going to pass incorrect code. And this is where we want to talk about our edge cases. So we have our common cases. These are the cases we're usually going to see. This is the usual operation. The uncommon cases, which are probably going to happen, but a little more rare than the common ones. And then finally, the edge cases. These are the specific inputs where the code should behave differently on just that input, which I guess it doesn't really behave differently on this example. But these are the inputs that we want to make sure we test. Well, we want to make sure we test all of them. But these ones specifically, usually 0 if your input is a number, empty string if your input is a string, empty array list, empty hash map. These specific situations where the code's going to do something a little bit different. And a lot of times in the homework descriptions, there's a separate bullet point. It's going to be like, write a method that takes these inputs, these outputs, this is what it should do, this is what it should do. And then there'll be a bullet point. If the input is an empty array list, this is what it should output. And it pretty clearly says this is an edge case. Make sure you have a test case for that. So test your edge cases as well. And now we're finally rejecting that incorrect solution, that second incorrect solution. And then we look at this and say, is this enough testing? And at this point, Autolab would certainly be good with this if this were an actual question that I was asking you to write a test class for. This would be perfectly fine. Is it actually enough? Again, that's a question you have to ask yourselves. If this were production code I was releasing to users, I'd probably want some inputs in the millions, make sure I'm not breaking on the very high values. I would probably want to add some code actually to handle integer overflows, something we're not going to worry about in 116, but you could make arguments that you would want more testing than this. But this is quite reasonable. I wouldn't be mad at anyone for stopping at this point. But if you're ever unsure, write a lot of tests. If you don't know, Autolab's saying, hey, you're passing incorrect solutions, and you're not sure where to go, just write more tests. Yeah?
When you test in the high numbers, is there like a specific number where you want to test, or you just make a random big number?
I just make random big numbers. It depends on the exact situation, like what the method is exactly supposed to do. For this, where there's not really much characteristics, I just pick random big numbers. I only went up to 100 for this example even. But there is something called integer overflow. An integer can only store up to 2 to the 31 minus 1. I had to think about it a second. Whatever that, it's like 2.4 billion, I think, roughly. So you can't store a value over that or negative 2.4 billion-ish. You can't store a number below that. So there are situations where I'm going to be worried about that if I know I'm expecting very large or very small or very large negative values. Then I'm going to be worried about that and start testing in that range. But other than that, I'll just pick a random big number. Again, overflows and underflows, not something I'm going to throw at you in 116. But that is something long-term, career-wise, something you'll have to keep in mind. Or Stack Overflows. We'll talk about that Friday, actually. Stack Overflow is definitely a bug. We'll talk about that Friday with recursion. We'll see a Stack Overflow. So write lots of tests, and not just lots of tests, but a lot of variety of tests. So I could write a lot of tests, and I've seen students do this. Some of you might do that this semester, and it's fine. You're learning about testing. But having a lot of tests, and they're all, say, positive integers. You could have 100 tests. I'll have students with 20, 30, 40 test cases, and not this exact thing, but it would be the equivalent of having 40 positive inputs for this single method, never having a negative and never testing their edge case. And they're just adding more cases trying to satisfy Autolab, and Autolab's not satisfied because they're all pretty homogeneous test cases. So not just lots of test cases, but lots of variety. Try to think of different test cases that are very different from each other. I'll have students where they have to test a list, and they have 10 test cases with lists of size 0, 1, or 2. I'm like, just make a list of size 3. Make a list of size 5. Like, make a bigger list. It's easy to have a bug that's not going to be exposed on 2, especially for that specific one. Drove me nuts. I have an incorrect solution that says, doesn't work on lists bigger than 2. And they'll be like, what's going on? Like, I think it's pretty clear. There's a miscommunication somewhere there. Somebody can help me convey that better, But I thought that one was really clear. And I had multiple students, like a lot of students, having that issue last semester. So hopefully I can word that better this semester, because I think there was a disconnect there. So testing in 1.16, when you submit your code to 1.16, it'll be tests in 3 different phases. I have 2 of those phases on screen. These first 2 are the same phase, so it's a little confusing. But first, I'm going to run your tests on a correct solution. So I'm going to take your test suite, I'm ignoring your code, and just taking your test, and then putting in my correct solution and running your tests. Your tests need to pass that correct solution. Then I'm going to take away the correct solution and put a purposefully incorrect solution, like the one that didn't handle the negatives. Run your tests again on that code. Your test needs at least one test case that's going to fail that code and correctly identify as an incorrect solution. And I'm going to do that for multiple other incorrect solutions. And once you get all the incorrect solutions marked as incorrect and the correct solution marked as correct, then I'm finally taking my test suite and running it against your code and making sure your code is correct. So those are the 3 phases where you'll be tested in 1.16. I make random big numbers. Yes. There, wait, and I won't have, this is exactly where I got in the other lecture. I'll save the testing tips for next time.